Welcome back, everyone, to our series on demystifying IPv4 subnetting, and you're going to love this episode because we are going to answer the question, how can we figure out how many hosts we can accommodate, and how can we figure out how many networks we can create? You might remember our IP address classes, and we saw, for instance, in the class C that there were 2,097,152 networks that were possible and 254 hosts per network. How in the world did we calculate those numbers? Well, let's take a look at just how easy that is to do. And the first thing we're going to discuss is how you calculate hosts. So in our example here, how do we calculate that there is 254 hosts available per Class C network? Well, it's very, very easy. All we have to do is memorize a simple formula. 2 raised to the number of host bits that we have minus 2. That will give us our answer. Now, one thing you might wonder about is, okay, what is the minus 2 all about? I mean, I get it that we're just going to count up the host bits and that's going to become our exponent. But what about the minus 2? What is happening here? Well, the minus 2 is because we cannot have all zeros in the host bits. Yeah, here's an example, 192.168.0.0 with a 255.255.255.0 mask. That is all zeros in the host bits, and that is identifying that network itself. So we have a minus 1 because we can't have all zeros, and we can't have all ones either. So that's the other minus value for our minus 2. Yeah, you can't set the host bits all to ones as we see here. What's happening here is you're actually using the broadcast address into that subnet. So the all zeros and the all ones cases, we subtract those. All right, well, let's take a look at an example then. You might remember this famous for our series address and mask combination. This was off of my laptop, 192.168.0.18 with the 24-bit 255.255.255.0 mask. Notice I have my conversion table on screen because that would always be in front of me whenever I am working with subnetting questions. And the question here is, of course, what's the number of hosts we can accommodate? And that is so easy. We know that we have 8 bits that are left here for the identification of a host. And if we plug that into our 2 to the h minus 2 formula, we're going to get 254. Yeah, 2 to the 8 would be 128 doubled for 256. And then when you subtract your 2, you get the answer 254. So when I saw the address and mask combination on my laptop of 192.168.0.18 with that 24-bit mask, I need to know that, yep, sure enough, my little home office network can accommodate 254 different hosts. Now, what about a formula for the number of networks? Well, this is so easy. We just take the number of bits for network assignment, and that becomes our exponent in our formula. So it's 2 raised to the n power, where n is the number of bits that we are utilizing. So let's take a look at this calculation. How do we get to this number of networks that are available in the Class C addressing scheme? Well, this is a little interesting. We have to remember that the first 3 bits are forced to 110. So that means we only have 5 bits to play with in the first octet. So if we have 5 bits to play with in the first octet and then we have 8 and 8 bits after that, the number of bits that we have to play with for network addressing here is 21. So 2 raised to the 21 is 2,097,152. Now, as you know, we would need a calculator to figure this out. So this is something that we would not be asked about in an exam environment unless they provide us with a calculator. So let's just prove this real quick. I'm going to say 2x to the y 21 equals, and sure enough, it's our 2,097,152. So we take the number of bits that we have for network addressing, and we just plug that into the 2 raised to the n power formula. It's that simple, folks. And don't worry, we're going to have lots more examples of this coming up, so you'll become very, very familiar, and in fact, you'll memorize these simple formulas and these simple calculations. Thanks so much for joining me.